Good morning, all. Am I audible?
Good morning, sir. Yes, sir, we are
Yes,
audible.
sir. Audible, sir.
So let's continue our discussion of we're doing numericals on how to find the electric field. No?
Yes, sir.
Yes, sir.
See, a system a system consists of a thin charged wire ring of radius capital R and a very long uniformly charged thread oriented along the axis of the ring with one end coinciding with center of ring. The total charge of the ring is Q. The charge per unit length of thread is lambda. Find the interaction force between the ring and the thread. Measure the question.
Understood, sir.
This is a thread. There is charge on this. So this is the ring. There is a thread oriented like this. One end is this. The other end goes to infinity. This is also having a positive charge. He's asking the force. Now what you will do is These are two objects. We'll consider small elements. If we take this dq at a distance of x, the length of dx, what will be this lambda dx on dq? What
Yes,
is
sir.
dq of this? Right. Now we can see that the electric field due to the ring is away from the ring or towards E due to the ring. So force dq of wire due to what? Do you agree with this?
Yes, sir.
Agreed.
So here df is dq into field due to the ring. This is lambda dx. Electric field due to the ring is how much?
By epsilon.
Do you agree with this?
Agreed, sir.
For see here x is 0, then x goes to infinity. So upon integration, in which direction actually?
Right from the ring.
Now by Newton's law, what is Newton's third law? From Newton's third law,
Acting like
minus of force on thread
Byron.
due to ring. So this is understood this,
Yes, sir.
that
and this is nothing but is it clear?
Sir, one doubt, sir. Sir, sir, interaction force means net force experienced by wire due to ring now, sir.
Hmm.
Then why we are taking opposite, sir, means force on ring by thread.
He said between the ring and thread, no? Did he say that force on the thread by ring? Huh?
Mm,
Between means force on ring by thread or force on thread by ring.
Sir, I didn't understand that, sir. I didn't understand.
Between is saying man, force between A and B means force on A due to B or force on B due to A
Force on A due to B.
or force on B due to A. Between he said.
Yes,
Between
sir.
ring and thread means both. Both are equal and opposite, no?
Yes, sir. Yes.
Understood, sir.
Shall I turn this?
1 minute, sir.
Pardon? Wait, you did not note down the question. Huh?
Last one.
Completed.
Yes, sir.
Yes, sir.
Now you can avoid integration and do the same problem. Suppose it's a wire. This is infinitely long. No? Now you need the electric field at any point, say for example R. Right. You have one is parallel to this. Remember this?
Yes, sir. Remember.
Because this side is zero, no? Remember this or not? Suppose this is a wire.
Yes.
This is theta 2, this is theta 1. You have this as
Sir, one doubt. One more doubt, sir. How
One.
you are
here.
taking this direction, sir? Downward direction. I'm not understanding.
You keep your brain and you work out, man. See, I am again writing here now. This is a wire. I want to know the electric field here. There are two components. Remember this?
Yes, sir. Two
Along
comma.
theta, along theta 2 you have theta 2 is here 0, no? And the other one is theta 1 is how much? The other one pi by 2, infinity, no? Remember
Yes,
this?
sir. I remember, sir. But
Same
how,
thing.
sir? But how you are taking downward direction, sir? That I'm not understanding.
Newman, here what I have taken? Upward, huh? What is this direction?
Downward.
Same thing I
How?
wrote here. Huh? How we get, we derived this. Look at that.
Yes,
This
sir.
derivation we have already done.
Yes, sir. I looked that, sir, but I didn't understand anything. That's why, sir.
Which one? The direction you don't know. Then how did you do yesterday evening problems, morning, all that based on this one, you know?
Yes, sir. Yesterday evening problem, I was about to ask that doubt, sir.
No man, this derivation we have done. Remember?
Remember, sir. Remember.
Same thing I am using.
Mm. Yes.
Remember once again I am telling for a wire, you take any point. This is the distance R. We have electric field has two components. Suppose this is theta 1, this is theta 2. Now one is towards theta 2 parallel to the y, towards theta 2. The other is perpendicular to the wire. Remember this? I told you
Remember,
to at least this. It is definitely you should know this. Both are same.
Sir,
If it
applied
is,
1 by 4 pi epsilon naught into lambda by r.
I derived this. I posted some reference books. Everything I have done. Now you can see that if the wire is very long, then you can see that this angle goes on increasing like that. So this angle goes on increasing till pi by 2. Suppose the point is here, then this angle is what? This angle theta 2 is 0, and this is, if it is infinity, this angle will be what? Theta 1 will
90.
be equal to pi by 2. Same thing I am using here. This is 1 by 4 pi epsilon naught. Agreed? So this
Yes.
is the perpendicular component, this is the parallel component. So see, already we derived the same thing. It's waste of time again and discussing. Now you have a ring here, a wire here. Now you can see this infinitely long wire now. So this case at a distance of r now, you have two components. What are those? Parallel component, perpendicular component. Throughout the ring you have this. One is a parallel component to the wire and one perpendicular component. Similarly, here also you have perpendicular component will be there, parallel component will be there. Here also you have perpendicular component, parallel component. Now if you sum up, force on ring due to wire will be what? Will be nothing but E parallel. Agreed?
Yes, sir.
Into charge on the ring is Q only, no? Agreed? So here R is nothing but capital. Understood this?
Understood, sir. Writing, sir.
Previously, I had taken the ring and found the electric field at the site or location of wire. Then I found the force on the wire. Now the other way, I am finding the electric field due to the wire at the location of ring. Then I am finding the force on the ring. You got the same answers if you want, you can check up. This will avoid your integrations, but the other thing you need integration. What days?
1 minute, sir.
Sir, doing, sir. 1 minute. So one more doubt, sir. So
Tell.
here in last problem, we wrote the direction of force is towards the center of ring. Here it is telling upward, no sir, means away from the center of ring, no sir.
Previously, how much you got? You got.
Same answer, sir.
And then
Direction different, no sir. Yes, sir. Completed, sir.
Sir, I have a doubt.
1 second. Wait.
Sir, that should be 4E parallel, right?
Hmm. E parallel.
Yes, sir, but we have to write 4E parallel because there are four components.
Hmm.
There are
Pardon?
four. There are four components of E parallel over there, right?
What
That's
for 1,000 are there? Not one. 1,000 components are there on each one. See, man,
yes, sir.
here
Yes, sir. Yes,
Yeah,
sir.
but
Sorry.
we can help you.
this is dq on the ring into E parallel. Sum of this. E parallel is same only, no?
Yes,
This
sir. Yes, sir.
is E parallel into integral of dq of the ring. That is E parallel into Q.
Understood, sir. Sir.
Any doubt is there?
No, sir. Understood. Answer.
Is it clear?
Sir, clear.
Yes, sir.
Right. Yesterday I gave those questions. You got anything?
But I couldn't get that triangle one. Equilateral triangle.
Okay, let us come back to this. What are null points, man?
Zero charge?
Null point. So these are the points at which okay, he'll ask you find, for example, there are two charges. One is 4 coulomb micro, 9 microcoulomb. They are separated by 30 centimeters, he gives. Find the null point, you say. See, then you have to check like this. See, suppose you take that null point, you keep plus 1 charge here. Now you can see this is A, B, C. What is the force on this due to this? Force on C due to A. This is what? Force on C due to B. Do you agree with this? Any
Yes, sir.
doubt is there?
Yes, sir.
Yes, sir.
Now
No.
you can see force on C, therefore at
No.
point C, the electric field can be zero. So net force and plus one charge is only the electric field now. Now can you
Yes, sir.
tell, suppose the distance between, suppose this is x, now I can say that magnitude wise 4 micro, this is x square, this is 9 micro into 1 coulomb by 30 minus x whole square. Agreed? So what you have 30 minus x whole square into 4. This is 9x square. Do you agree with this? If we take this 60 minus 2x is 3x. 60 equals 5x. X equals 12 centimeters. That means null point is at 12 centimeters on the left charge. Is it clear?
Yes, sir.
Now suppose we are having dissimilar charges. Now you can see if you keep any charge here, say for example C, this is A, B. This is force on C due to A, force on C due to B. So here cannot sum up to 0 now. Therefore, we cannot have null point at C. Do you agree with this? Any doubt?
Great, sir.
So the only
Great, sir.
possibility is you have to check up whether it lies outside or not. Now if I take a point D here, you can see that this 5, 4, this is mine. So if you keep plus 1 here, this is force on D due to B. This is a possibility or not?
Yes, sir.
That means if this is X, again the same story. What is that? 1 by 4 pi epsilon naught. Yet you have 4 micro into 1 by x square. 1 by 4 pi epsilon naught 9 micro into 1 by 30 plus x whole square. You will find x. Understood how to find null points?
Yes, sir.
Yes, sir. Yes, sir. Understood.
What is null point? How to find null points? Shall I turn this?
1 minute.
1 minute.
Equal to 50%.
Got this? Shall I
Yes,
turn
sir.
this?
1 minute, sir. 1 minute.
Yeah.
After the class, work out the problems. If you have any doubt in that notes, again you can just take the photo of that and post it to me. I shall again discuss that particular issue.
Yes.
Shall I turn this?
Yes, sir.
Yes.
So you have the motion of charged particle. But the second year learning may be difficult, concepts are more, but scoring is easy compared to first year. In electric field. See, you have seen that F is equal to F by Q is what? So F is you remember that no charge can experience force due to its own charge.
Yes, sir. Right.
Followed? Is it clear?
Clear, sir.
So I can say that under the influence of electric field, experiences, okay, whether understood this, whether it is at rest or in motion, it always experiences a force. So you can see that suppose this is the external field, you place a positive charge here, it will have a force in the direction of this. On the other hand, if you have an electric field in this direction and you are having a negative charge here, so it will experience a force in this direction. Followed this? Clear?
Clear, sir.
So I can say that understood this.
Yes, sir.
Yes, sir.
Shall I turn this?
2 minutes. Right.
1 minute.
Completed.
No, sir. Writing that paragraph.
Finished?
1 second, sir.
1 minute, sir.
Done, sir.
1 minute, sir. 1 minute, sir. Done, sir.
for example, this charge is negative. Now, in a gravitation field, it is own weight, it will fall down. Now, in which direction I should keep the electric field? If I switch on an electric field like this, the negative charge will experience a force like this now.
Yes, sir.
So you can see that force on negative charge will be in which direction? Sorry.
Upward direction.
So charge will be in equilibrium. Mg is balanced by P. Understood this?
Yes, sir.
Now suppose you are having a positive charge. It falls like this. Now we need upward force. Upward force means this positive charge. Field should be in which
Electron
direction?
force acting upward.
Upward direction.
Electron.
Balance that. Understood this?
Yes, sir.
And sometimes he'll be asking this also if you want. Remember this? N is the number of electrons. Remember this or not?
Yes, sir.
Yes, sir. Remember, sir.
Shall I turn this?
1 minute, sir. 1 minute.
After every class, go to the notes. Any doubts are there? You can just take a photograph of that and send it to me. I'll explain next day.
Yes, sir. Thank you, sir.
Done, sir.
Completed, sir.
Right. Now suppose we are having a situation wherein this is a negative charge. Now this is Mg. If electric field is in this direction, so we have seen that Mg equals Qa. Now suppose we are having a situation electric field is reversed. Then what will happen? So what is the acceleration of the charge?
Mg plus
Mg plus Q.
But you know Mg is nothing but Qe only, no? What is Mg? Qe only, no? Already you got this, no? Mg can balance Qe only, no?
Yes, sir. Yes, sir.
Yes, sir.
Sir, one doubt, sir.
Sir, but
Hmm.
Mg can be Q only when it is in equilibrium.
Yes, sir.
Mg, yes man, but that value will change, eh? I don't understand.
No, no, no. Yes, sir. Yes, sir. That will not.
This is 10, this is 10. Both are, that
Yes.
value won't change, no?
Yes, sir, yes.
Acceleration will change.
Yes, sir. Yes, sir.
So you'll get 2G, no? Do you agree or not?
Yes, sir.
Done, sir.
Is it clear?
Yes,
Clear.
sir.
1 minute, sir. Done, sir.
So in case, usually the acceleration will be that is, suppose in the question he has given that gravity is ignored. Then you can see that suppose the electric field is this side, then positive charge will be having a force here. Due to this, there is an acceleration. Remember all this?
Yes, sir.
So this is a constant only, no? So since it is constant, kinematic equations can be applied now.
Yes, sir.
Suppose you need the if the charge initial velocity is at rest. Then velocity after time t is nothing but QE by m into t. Do you agree with this?
Yes,
Agreed.
sir.
Then again you can see displacement. This is anyhow zero starting from rest. Otherwise, you'll give some value. What is it? Understood this?
Understood, sir.
So, shall I turn this?
1 minute, sir.
Also, you know, in this case, you can apply that work done by all forces is change in kinetic energy. Here, electric force displacement cos zero, no? Finally, half mv square, initially zero. Do you agree with this?
Yes, sir.
Agreed.
Yes, sir.
So these are the various equations. Depending on that, you can find out whatever problem is given. You can apply. Understood this?
Yes, sir. Understood.
Understood, sir.
So this is the key final now. Shall I turn this?
Yes, sir. Done, sir.
Yes, sir. Completed.
See, suppose it's a plate, a sheet of charge. Electric field will be this side only. Remember this? Now suppose it's a negative charge, sheet of charge. This is also a sheet of charge. This is a negative charge. Do you agree with this? Can you tell what is electric field towards this? Remember this?
Yes, sir. Agree.
Non-conducting means this one, you know.
Sir.
Do you agree till here? Any doubt is there?
No, sir.
So now I am taking one positive one and one negative. So can you tell the net field will be in which direction? Due to this, it will be like this one, you know. Due to this, it will be like this one, you know. So what is the net field?
E
Do
is
you
equal
agree
to
with this?
epsilon. Yes, sir.
That
Yes,
means
sir.
whenever
Sigma by
I
epsilon.
so whenever I keep a positive charge plate, and this is a negatively charged plate, then the electric field is from positive to negative. Agreed?
Sir.
Till here any doubt is there?
Sir,
No,
negative
sir,
means
no doubt.
E should be upside, no?
Towards the plate when? What upward?
Yes, sir.
Look at not the arrow you don't take, but it's towards or away you see. Towards. This
Yes, sir.
figure a reverse and see you'll get the same thing. Understood this?
Yes, sir. Understood. One minute,
Now,
sir.
Yes, sir.
Done, sir.
1 minute, sir. 1 minute, sir. Last name. Done, sir.
so now suppose you are having a situation that you are having two plates like this. Okay. Now this is the positive plate, the negative plate. You know that electric field is directed like this. Now here a positive charge is shot with a velocity u. See the length of the plate is L. This is green. So naturally this positive charge will be attracted or repelled by this. What is the acceleration of this?
But downward, sir.
Okay, we'll take this as a negative for example. If it is negative, it is attracted like this now. So net force will be upward now.
Upward, sir. Yes, sir.
So this is diverted like this, and somewhere it comes like this. Then after that, it follows. Till here, it follows a projectile path. Understood this?
Understood,
You
sir.
Yes,
agree
sir.
with this? Because it deviates in the direction of acceleration. Remember, in a projectile motion, when you are projecting like this with an angle theta, this is the acceleration g. So it deviates towards the acceleration. So here also it deviates like this. So once it comes out of the plates, it goes straight. Because there is no more, I am neglecting the gravitational force. Till here, any doubt is the situation?
Excuse me, sir.
Tell me.
Sir, the electric field due to positive plate and electric field due to negative plate will both sum up and it will be downwards, no, sir? That
Downwards only I
force
will
will
take it.
also act, sir.
Huh?
That
What?
force will also act, no, sir?
That force only, man. Electric field is the downwards means for what is the force on this? Field is downwards, force is upward. No,
Yes, sir. Yes, sir.
I have taken that only. So this is QE. So what is the acceleration here? Understood this?
Yes, sir.
So here we will write the equations with the displacement along x-axis. Ux is how much? Ut. There is no acceleration. Then displacement along y-axis. So this is y. Till here, any doubt is there?
No doubt.
No, sir.
That means at any point, see, this is supposed to go like this. If I take this as the origin, then you have this as y, this as x. So this is the point x comma y at t. This is at t equals to 0. Understood this?
Yes, sir.
Yes, sir.
Now you can eliminate. Understood why first year is so important and
Yes,
why
sir.
physics becomes difficult is this only. When we tell in first year, people won't even bother to hear. Now a person cannot suddenly pick up in second year, leaving all first year. Okay, till here you followed now. So what is this path? Y is proposed to x square. What is
Yes.
that?
Parabola.
So the path is a parabola. Understood this?
Yes, sir.
Yes, sir.
Now suppose if he asks Vx velocity, what you can do? This is u. What is Vy? Understood this?
Yes,
You
sir.
can find whatever is asked, you can find in the question, depending on the question. Now sometimes he'll ask what is the deviation. Shall I turn this?
1
One
minute,
minute,
sir.
sir.
Return this.
Sir, one
Yes,
minute,
sir.
sir,
Done,
please.
sir.
Sir. Yes, sir.
Completed.
Yes, sir. Completed.
Yes, sir.
Now suppose, see these are the various method of solving the problems. He'll give a situation wherein don't mug up all these formulas. There is no use in this. Now when you are projecting with U, it is supposed to go here, but you can see deviates and hits somewhere here. He will say what is the deviation suffered. Say suppose this is D, this is also the distance between the plates. Okay. Now you can
Yes,
see
sir.
what is deviation, can you tell? Suppose this is the velocity when it comes here, Vy. Okay, this is Vx. This is the total V, no? Any doubt is that till here?
No, sir. No doubt.
So,
Do you agree with this?
Yes,
See,
sir.
deviation means the initial velocity. Suppose there is no electric field, it should have gone straight. Due to the presence of electric field, it is going in this way.
yes,
This
sir.
angle is called the angle between the final velocity and initial velocity. Is what you call it as angle of deviation. Now you can see if this is theta, this is also theta one, you know. So what is tan theta man? Agreed?
Yes, sir.
You can find Vx if you want. 2, so Vx is nothing but u square. No? U. Do you agree with this?
Yes, sir.
Yes, sir.
Vy square, there is no velocity. Qu by m. By the time it comes over here, you can find the displacement delta y. Okay? Or
Yes,
you
sir.
can use Vy equals Uy plus Ayt. This is 0 Qe by m. T is nothing but x by
X
u.
by
When it comes here, what is x? Alone, no? Understood this? How to find?
yes,
These are numericals you'll come across. Shall I turn this?
1 minute, sir.
Any doubt?
No, sir. No doubt.
Shall I turn this?
1 minute, sir. Done, sir.
See, we'll be saying that suppose a particle is projected like this in this direction at an angle of theta. So the particle has So suppose the electric field upward. What is the net force on the particle? Agreed.
Yes, sir.
Therefore, what is the acceleration downward? Follow this or not?
Yes, sir. Yes, sir.
Now you can find the velocity at any time if you want. What is Vx? This is nothing but because there is no acceleration. No? What is Vy?
You cos theta plus G minus Q by V by M.
This is the velocity. Likewise, you can get the velocity. I'm telling the method of how to solve the problem. Okay. Now again you can find delta x is 0 no at any time t. This is u cos theta into t plus 0. Do you agree with this? What is delta y? This is u sin theta into t. Do you agree with this? Therefore,
Yes,
position
sir.
vector you can get. Remember this.
Yes, sir.
Yes, sir, remember.
Is it clear? Like that, you can find the given whatever is asked, you can do using the principles you already know. So, for example, we have here this is a velocity vector. You have Vx, you have Vy. Okay, what is the direction of velocity means? Suppose this is the angle is some alpha. What is tan alpha you'll get?
Vy by Vx.
So like that you can find out the wanted quantity. Okay.
Yes, sir.
So return this.
1 minute,
1 minute,
sir.
sir.
Complete it.
1 minute, sir,
1
1 minute.
minute, sir.
Shall I turn
Done, sir.
this?
Yes, sir. Done, sir.
Suppose we have a simple pendulum. Is a simple pendulum. See, for example, this is plus Q. Okay. Now you can see with the electric field in this direction. Then it is experiencing a force how much QE, and this is mg. So what is the G effect you will take? Mg
Sir,
won't be acting because that is part is balanced by QE, no? Suppose this
one
is
doubt,
100, this is 20. Totally you'll have 80 downwards, no?
sir. One doubt, sir. Please, sir.
Tell.
Sir, Q
Yes, sir.
is downward, no, sir.
Yes, sir. QE should be downward, no, sir.
Yes, sir. Clear,
Okay.
sir.
Yes, sir. Understood.
Like that you will be having problems on simple pendulum. Almost whole first year they can link up. Now suppose you are having a situation, then you can see that understood this.
Yes, sir.
Sir, one more doubt, sir.
Tell.
Sir, in the string there will be tension, no, sir. Why we are not considering that?
See, this formula is derived. Problem is people won't concentrate when I taught. Here, this formula was derived taking tension into consideration only.
Yes, sir.
Remember this. We have considered tension. Finally, we got this. That means
Yes, sir.
here which parameter is there? G.
G.
Now, there is no external field. G will be 9.8 only. But when the external field is there, G will be effect. Total will not be there. Now, for example, mg is 100. You are applying 20 upward. What is the net field downwards?
80.
100 minus 100.
80. So I have taken that net one. Again, why to derive the whole thing? You want to consider tension and all. Again, you should derive the whole thing for this equation. Already I derived this, no?
Yes, sir.
Yes, sir.
Yes, sir.
That's why I am taking G effective. I am not taking net force. Remember, this
Yes,
is
sir.
not net force on the bob. Effective G experienced by the bob. Understood this?
Yes, sir. Understood.
Shall I turn this?
1 minute, sir. Done, sir.
Now suppose there is an electric field like this. Suppose a bob here. We switch on an electric field in this direction. Being positive charge, the force will be like this. The bob will rise here. So there is a force here. Agreed.
Yes, sir.
So what is the effective G now in this case? They are perpendicular now. Agreed.
Yes, sir.
Instead of deriving, I am taking the same available one. Already have this now.
Yes, sir.
I am seeing the how the electric field will affect the gravitational force already present.
Yes, sir.
Shall I turn this?
1 minute, sir.
1 minute, sir.
See, if you remember the derivation briefly, at any position theta is the tension. This is also theta. Remember this?
Yes, sir.
Out of
Yes,
this
sir.
torque about O, if you take, due to this, it will be, the problem is you did not read all this. So you have only torque due to mg sin theta now.
Yes, sir.
Remember that force into perpendicular distance. Now this
Yes.
is the distance. What is the torque direction? You can see this torque is this way now. Agreed.
Agreed, sir.
Yes, sir.
Agreed, sir.
Then you have taken theta and this theta is in this direction. Theta is anti-clockwise. Torque is clockwise.
Clockwise.
So now I can take for small angles is equal to I alpha. No, what is I? Remember this? Why I have taken negative sign? Because understood this. This we have
Yes, sir.
taken as omega square theta. So what is omega? You have G by L. T equals 2 pi by omega. Remember all this?
Yes, sir.
So here you can see, Jasim, is the role of tension there anywhere?
No, sir. Torque is zero.
That's what. That is the reason why if you want to take electric field again, you have to resolve electric field also along this. Same thing you will get. So that means in the time period, the forces along the thread, okay, the tension is not other than mg component. Tension is not playing. No,
Yes,
Not
sir.
playing, sir.
that means component of mg perpendicular to thread is only playing now.
Yes, sir. Mg sin theta.
Yes, sir.
The story understood this till here.
Yes, sir. Understood.
Time period will not be affected by forces parallel to the thread. Any doubt is there?
Yes, sir. No doubt.
No, sir.
Remember that any force that is parallel to the thread will not affect the time period.
Time period.
The same, followed. The fellow left.
Sir, followed, sir. Sorry, sir. Time taken for opening speaker.
Shall I turn this?
1 minute, sir.
Shall I turn this? Hello?
Sir, 1 minute, sir. Please, sir. 1 minute, sir. Yes, sir. Completed.
So, 1 minute you can go. I'll just conclude this. Just 1 more minute you can go. Suppose you're having a situation like this. There is no electric field. E is not there. Then only G is present. Then what is the time period? 2 pi root over. Now suppose we are keeping another charge here. This is Q. What is the time period? What is the time period?
E by
2 pi under root of L by G.
Why? Since
Because only G is present.
this is path.
since forces
Parallel won't
parallel to string will not
Not change
affect.
affect
time
the time.
period.
Understood this story?
Yes, sir.
Right then. Complete this. We'll get back in the evening and avoid absenteeism. It will be a problem. Okay then. Right then. Take care. Bye.
Thank you, sir.
Bye,
Bye,
sir.
sir.
Bye bye
Thank you, sir. Take care, sir. Bye, sir.
bye. Bye bye bye.
Thank you, sir. Bye.